Hi all, in this video I am going to explain most important MCQs in root locus. So don't skip the video. Problem number 1. A unity feedback has an open loop transfer function g of s is equal to k divided by s square. The root locus plot is open loop transfer function is given. So I am going to write the open loop transfer function once again. G of s is equal to k by s square. To draw any root locus plot, first of all you should know how many poles and how many zeros in the open loop transfer function. In this transfer function, there is no poles, no zeros existing. But how many poles? 2 poles are at the origin. S square equal to 0, s is equal to 0, 0. 2 poles at the origin. Next, I am going to find out how many root locus branch for this transfer function. According to the number of poles, there may be 2 branches in the root locus. So, number of branches in the root locus is 2. Here there is no zeros, so 2 root locus branches terminates at infinity. And next I am going to find out the angle of asymptote. What is the formula? Plus or minus 2q plus 1 divided by n minus m into 180. How many asymptotes are there? N minus m, 2 minus 0, there are 2 asymptotes, that is 0, 1. First of all, I am going to find out q0, pi 0, that is the first asymptote angle, by substituting q is equal to 0. So q is equal to 0 means 2 into 0 plus 1, 2 minus 0, so 1 by 2 into 180, that is 90 degree. Next I am going to find out pi 1. So 2 into q is equal to 1, 1 plus 1 divided by 2 into 180. So 3 by 2 into 180, that is 270 degree. Next I am going to find out centroid. What is centroid? Summation of poles. So how many poles? There are 2 poles, the value 0, 0. So 0 minus 0, there is no 0, 0 divided by 2 minus 0, number of poles minus number of zeros. The answer is 0. So which diagram is correct? The option B, there are 2 poles at the origin. So we have to mark the poles at the origin. Then what will be the asymptote angle? The asymptote angle is 90 degree and 270 degree. So this is the asymptote angle. And here the centroid exists. So what about the root locus branches? One of the branch they go to minus infinity and here minus and plus infinity. So both are terminates at infinity. Option B is the correct answer. Next, given a unity feedback system with open loop transfer function g of s is equal to k into s plus 2 divided by s plus 2 the whole square. Correct root locus plot of the system. Here first of all find out the number of poles. How to find out the poles? Denominator polynomial equal to 0. So s plus 1 the whole square equal to 0. S is equal to minus 1, minus 1. Repeated roots in the minus 1. Next 0. How many zeros are there? Numerator polynomial equal to 0. There is only 1 0. S is equal to minus 2. Now I am going to mark here the minus 1 repeated poles are there. So I have to mark the poles like this. This is the way of representing the repeated poles. And then 0, that is minus 2. How many root locus branches? According to the number of poles, root locus branches are 2. So one of the root locus branch that is connected to the terminate in the 0 given, and another one is terminate to infinity. Okay, see these both the root locus branches, that is always the root locus branch starts from open loop 0. This is open loop pole. Here this is the open loop pole and ends at infinity and ends at 0. Here one of the pole, this is one branch and this is the next branch. The first branch ends at infinity means the second branch ends at infinity. First branch ends at 0. So which one is correct? The option C is the correct answer. Next problem. The closed loop transfer function of the feedback control system is given by C of S divided by R of S equal to K divided by S square plus 3 plus K into S plus 2. First of all, I am going to find out the characteristic equation. So which one is the characteristic equation? That is the denominator polynomial of the closed loop transfer function is the characteristic equation. How to represent this is 1 plus GS. That should be equal to S square plus 3 plus K into S plus 2. And rewrite the equation like this. 1 plus G of S equal to 1 plus S square plus 3S plus KS plus 2. No. Have to separate the, I'm going to separate KS. So what I have to do? Have to divide the equation by S square plus 3S plus 2. I have to do like this, S square plus 3S plus 2 plus KS. And next I am dividing the equation by S square plus 3S plus 2. 1 plus, I'll get the equation 1 plus KS by S square plus 3S plus 2. Okay, this is the second line. And third, G of S. What is G of S now? G of S equal to Ks divided by S plus 2 into S plus 1. How many zeros? There is only one zero. And how many poles? There are two poles. One is minus 1 and another one is minus 2. How many root locus branches? There are two branches corresponding to two numbers of poles. So one of the branch is terminate at 0 and another one branch is terminate at infinity. Okay, so I have to draw this, have to mark the poles. Here minus 1 and this is minus 2 and 0 is, this is open loop 0. See here, I have to consider one point P1. So to the right to this point, how many poles and zeros are existing? That is odd numbers of poles and zero. So there will be one root locus path. Here this is the path. And next I am going to consider the next point P2. See, there is 2 only. There is even number of poles and zero exists. There is no root locus in this point. And next, here consider this. Only 1, there is odd numbers of 0 exists, there may be a root locus point. Okay, in this portion only we are having the root locus. So minus 1, that is terminated at 0, that is open loop 0, and this one is terminated as open loop and that is infinity. Okay, which one is the correct answer? B is the correct answer. Next, the open loop transfer function of a feedback control system is given by G of S into H of S is equal to K into S plus 2 divided by S into S plus 4 into S square plus 4S plus 8. In the root locus diagram of a system, the asymptotes of the root loci for large values of K meet a point in a S-plane. Which one of the following is a set of coordinates of the point? So what is set of coordinates? That is similar to the centroid of the root locus, because asymptote that is finally meet in a centroid. So here I am going to find out centroid. So what is centroid? Sum of real poles minus sum of real zeros divided by number of poles minus number of zeros. First of all, I am going to find out how many number of poles. So poles are s is equal to 0, s plus 4 equal to 0, that is minus 4, then s square plus 4s plus 8 equal to 0. Have to apply the formula minus b plus or minus square root of b square minus 4ac by 2a. So minus 4 plus or minus square root of 4 square 16 minus 4 into 8, that is 32. So minus 4 plus or minus j4 divided by 2. That is equal to minus 2 plus or minus j2. So this is the third and fourth pole. Minus 2 plus or minus j2. How many zeros? Only one zero. Zeros minus 2. Next I am going to apply these values in this equation. We get the centroid. Sum of poles 0, minus 4, real value of poles. So real value means I have to take minus 2 only, minus 2 for the 2 poles, plus how minus of minus 2, that is the 0, divided by how many poles, that is 4 numbers of poles, and how many 0, only 1. So minus 4 minus 2, that is minus 6, divided by 3, that is minus 2. So option B is the correct answer. Next, problem number 5. If the characteristic equation of a closed loop system is 1 plus k divided by s into s plus 1 into s plus 2 equal to 0, the centroid of the asymptotes in root locus will be. Here find out the centroid. Before that, first of all, I am going to write g of s is the open loop transfer function k divided by s into s plus 1 into s plus 2. How many poles? Poles are 0, minus 1, minus 2. How many 0? There is no zeros in this equation. Next, find out the centroid. Sum of poles minus sum of 0 divided by number of poles minus number of zeros. Sum of poles is 0, minus 1, minus 2, then minus 0, divided by number of poles. How many numbers? There is 3 numbers of poles and only 1 0. So minus 3 by 3, that is minus 1. C, option C is the correct answer. Next, the root locus of a unity feedback system is shown in the given figure. The open loop transfer function of the system. So, see here, how many poles? There are 2 poles, one is 0 and another one, minus 1 and another one is 0. Only one 0, that is minus 3. So you see this option, only one 0, that is minus 3, and 2 poles, one is 0 and another one is minus 1. So which one is correct? Option C is the correct answer. Next, problem number 7. The open loop transfer function of a feedback control system is k divided by s into s square plus 3s plus 6. The breakaway point of its root locus plot. So how to find out the breakaway point? So breakaway point should be between 2 poles. 2 poles, the breakaway points exist. So first of all, I am going to find out how many poles in this transfer function. Poles equal to first pole 0. Second, how to find out s square plus 3s plus 6 equal to 0. So minus b minus 3 plus or minus square root of 9 minus 24 divided by 2. Minus 3 plus or minus square root of minus 15. The value is j 3.87 divided by 2. So minus 1.5 minus j 1.936. So here I have to mark the poles first. The first pole is 0. Second one is minus 1.5 plus J 1.936. Here minus 1.5 minus J 1.936. Okay, here how many poles? There are 3 numbers of poles. So 3 branches in a root locus. 3 branches. I have to consider one point P1. Is there any root locus exists? From this point to right, how many poles are there? There are 3 numbers of poles are available. So 3 numbers of poles are there. So there should be one root locus point is exists. So this is the region of root locus. And next, I am going to find out the another 2 root locus branch. Here there is no breakaway point. Breakaway point because there is no neighboring poles are available. No breakaway point. There is no intersection in imaginary axis. So I am going to find out the asymptote angle here. So what is asymptote angle? Asymptote formula is 2q plus 1 divided by n minus m into 190. What about the value of q? So how many asymptotes are available? N minus m. So n is 3, m is 0. 3 asymptotes. So q value is 0, 1 and 2. First I have to apply q is equal to 0. So the answer is 1 divided by 3 into 190. The first one is 60 degree and second 2 into 1 plus 1, that is 3 by 3 into 190. So next angle is 190 degree and the third angle is 5 by 3 into 190. That is equal to 300. And I am going to find out centroid also. What is centroid? Centroid equal to summation of poles minus summation of zeros divided by number of poles minus number of zeros. So summation of poles, that is 0 minus 1.5 minus 1.5, there is no zeros available. 3 minus 0. Minus 3 by 3, that is minus 1. Here I am going to mark the minus 1 value. So this is minus 1. The asymptote angle is 60. So I have to mark the asymptote also. This is 60. Okay, now what about the root locus region? Here this is the one of the region and the next region may be it follows the asymptote and tends to infinity. Okay. So how many breakaway points? Is there any breakaway point? There is no breakaway point. So do not X. Problem 8. Match list with list 2 in respect of open loop transfer function. G of S into H of S equal to K into S plus 10 into S square plus 20S plus 500. And denominator S into S plus 20 into S plus 50 into S square plus 4S plus 5. First of all, I am going to find out number of poles. How many poles? 0, minus 20, minus 50. Next another 2 more poles are available, that is in the complex values. I am going to find out the complex values. S square plus 4S plus 5 is equal to 0. Minus b plus or minus, that is b square 16 minus 20 by 2. So minus 4 plus or minus j2 by 2 minus 2 plus or minus j1. Poles are over. Then how many zeros? One of the zero is minus 10. Another one I am going to calculate is square plus 20s plus 500 equal to 0. So minus 20 plus or minus 400 minus 2000 divided by 2. Now minus 20 plus or minus j40 divided by 2. Because 400 minus 2000 minus 1600 or 1600, root of 1600 is 40. So minus 10 plus or minus j20. Have finished the zeros also. And next I am going to mark the number of poles and zeros in the root locus plot. First mark the poles 0, minus 20, then minus 50, minus 2 plus j1, minus 2 minus j1. Then mark the zeros. Zeros are marked like this. Here minus 10, then minus 10 plus j20. This is also a 0. Another one 0 is available, minus 10 minus j20. Okay. Now I am going to find out number separate loci. So how many separate locis are there? Separate loci means number of root locus region. So how many root locus regions are there? It is same as the number of poles. So how many number of poles available? 1, 2, 3, 4 and 5. So number of root loci, that is 5. N is equal to 5. I have to mark it to 4. Then loci on the real axis. So real axis, how many root locus region? That is 3. And how many asymptotes? How to find out asymptotes? Asymptote is equal to how to find out n minus m. That is the formula. How many numbers of poles? There are 5. How many numbers of 3 zeros? There are 3. 5 minus 3 equal to 2. That is number of asymptotes. And how many breakaway points? Breakaway point between two poles. See, in this root locus, have to consider one point here. This point to right of the root locus. How many poles are there? 1, 2, 3, 4, 5, 6, 7 and 8. So there is no root locus region here. There is no root loci. And here I have to consider the next point. The next point is P2. And see how many number of poles and zeros available? 1, 2, 3, 4 and 5. So there may be one root locus region. And next I am going to consider in this point also there are 4. Here I have to consider this point P3. From P3 to this, how many poles and zeros are available? There is 4 numbers, again even. So there is no root locus here. And next I am going to consider the last point P4. The last point, there is only one odd number of poles available. So there may be a root locus path. Okay, but the breakaway point always occur between two poles. So we are having only one breakaway point. Here 1, 0 and 1 pole. There may be no breakaway point here. Only one breakaway point between these two poles. So breakaway point is 1. So what about the answer? The answer option D is the correct answer. Next problem. The characteristic equation of a linear control system is a square plus 5ks plus 10 equal to 0. So first of all, I am going to find out g of s from this equation, and I have considered h of s equal to 1. So 1 plus g of s into h of s equal to s square plus 5ks plus 10. And h of s equal to 1, 1 plus g of s equal to, have to rewrite the equation like this, 1 plus 5ks divided by s square plus 10. This 5ks divided by s square plus 10, that is known as g of s. I am going to find out how many numbers of zeros and how many numbers of poles. Zeros are 1, that is 0. Poles is square plus 10. S is equal to plus or minus j 3.16. Have to mark the pole here. So this is my root locus. Here I have to mark the 0 and I have to mark the pole. One is minus j 3.16 plus, this is plus j minus j 3.16. Okay, then I am going to find out the centroid. What is the centroid? The centroid is, that is sum of poles. So sum of poles is 0, real poles, 0 minus 3.16 minus 3.16, that is 6.32, not 6, 6.32, 3.16. So I have to mark the centroid here. Centroid is minus 6.32. Okay, then find out the asymptote. Asymptote, how many asymptote? N minus m. N minus m is number of poles. Number of poles 2. Number of zeros 1. So only one asymptote, that is q is equal to 0. Put q is equal to 0. 2 into 0 plus 1 by 1. That is 190 degree. So this angle, that is 190 degree. Okay, 190 degree angle. Okay, now how many branches of the root locus? So there are 2 numbers of branches corresponding to 2 poles. So 2 number of branches in the root locus. Okay. This 2 number of branches, it is started from open loop pole and ending at open loop 0. Okay, here the 0 is there. So it is starting from open loop pole. So to open loop pole and it is ending at 0. One of the point is ending at 0 and another one is ending at infinity. One is terminated at 0 and another one is terminated at infinity. Okay, option A is the correct answer. Next, the characteristic equation of a feedback control system is given by s square plus 5s square plus k equal to 0, k plus 6 into s plus k equal to 0. In the root loci diagram, the asymptotes of the root loci for large k meet at a point in a s-plane whose coordinates are. Asymptote normally meet in the s-plane, that is known as centroid. So this is asymptote that is meet in a centroid. So first of all, I am going to write the equation s cube plus 5s square plus ks plus 6s plus k equal to 0. Now I have to rewrite the equation as s cube plus 5s square plus 6s plus k into s plus 1 equal to 0. Now what is the next step? Divide the total portion, this portion, the entire equation. So 1 plus k into s plus 1 divided by s cube plus 5s square plus 6s. Okay, that is the value of g of s. Okay, what is g of s? K into s plus 1 divided by s cube plus 5s square plus 6s. I have to take s outside. So inside s square plus 5s plus 6. I have to separate this s plus 3 into s plus 2 into s plus 1 in the numerator. This is zeros and this one is pole. So how many zeros? There is only one zero, that is minus 1. How many poles? 0, minus 3, minus 2. So summation of poles 0, minus 3, minus 2. Summation of 0, that is plus 1, divided by how many poles? 3. How many zeros? 1. So minus 6 plus 1 minus 3 minus 2 minus 5 plus 1 minus 4 divided by 2, that is minus 2 comma 0. Option C is the correct answer. Thanks for watching. Have a nice day.